Welcome to the Screencam of our interactive explainable AI tool. So here we start with the Dataset Explorer that allows us to gain an overview over the underlying dataset. The underlying dataset is the German credit dataset, which contains 1,000 loan applications. And here we can see that a selection of 5 attributes is shown. In total, the dataset in the version that we are using has 18 attributes, but we only show 5 for a better visual overview. And in addition to those 5 attributes, we can also see the AI recommendation and AI confidence. And those refer to the underlying AI model that was trained on that dataset. And here it tells us the recommendation, whether the application should be approved or rejected, and also the confidence. The confidence depends on the approval or rejection probability from the model. And when we hover over those info buttons here at the top, we can see a short description about this attribute or recommendation and just a short explanation about what this is. We can now scroll through this table, and dynamically all of the 1,000 applications are loaded, and we can see whether they've been approved or rejected, and also the other information. And we can see that while scrolling, this table header sticks, so we always have an overview about which attributes we're currently looking at. Now we can go back up by using that arrow, and we just want to see a certain selection of those applications now. So we go to the filter menu. And here, for example, we say, okay, I just want to see those applications where the applicant had no balance. So we press apply, and we already see that just some applications are shown. And now we also say, okay, I just want to see applicants who are older than 52. So now I have a selection according to the filters that I've set. I can now reset the filters, and I'm back to the overview of all applications. And also I can customize the menu, because as I've said, we only show 5 attributes of 18. And when, for example, now I say, okay, I'm not that interested in the duration, but I want to instantly see the history, I can change it here. And I could also say, okay, instead of the employment, please show me the other loans information. And when I apply these changes, I can see that my initial table changes. And yeah, I could also then do other changes. So I can always adapt what I see here. So after gaining a first overview over our dataset, by using this Dataset Explorer, we now want to dive deeper into a specific instance. So here we choose instance 6, and we get to some sort of analytical view to this specific loan application that we have selected. It gives us at the top a detailed overview where we can now see all 18 attributes and also the AI recommendation and confidence. And here at the button, we have the 3 explanation types, which are different methods of explainable AI. And those can be helpful because we have this model in the background, this trained AI model, which has a high accuracy, but it is a black box model. So it is a neural network with a couple of layers, and we do not exactly know what it is doing. So when it gives us some decision like approve or reject, we do not really know which factors influence that decision, which can make it hard to trust the model. So the aim of these explainable AI models and methods is to give us some trust or some understanding for the underlying AI model. And here we start with DICE, which is a method for counterfactual generation. And when we just quickly want to know what that is or what that means, what we see here, we can hover over this info button and we just get a really short explanation or overview. And now we can take a look at it. So here we can see at the top in blue values of the original application, and below that we can see in orange how these values would have to be changed in order to receive a different AI recommendation which in this case would be reject with 88% confidence. And so in this case, for example, if we had an instance where all other attributes stayed the same, but these 5 were changed according to what we see in orange, then it would lead to this changed AI recommendation. So in this case, it would be no balance, no savings, no assets, loans at other banks, and rent instead of own housing. And this also kind of intuitively makes sense because all this would indicate a worse financial situation of the loan applicant. So this can help us to gain some trust in the model because we look at it and we think, okay, yeah, it makes sense what it does. And after looking at this, we also have 4 other counterfactuals that we can all go through, and that all suggest some changes made to that initial application, which would change the AI recommendation. So, after having gone through this, we can now take a look at the next explainable AI method, which is LIME. And here we can see that we have a different visualization. Now it's not a table anymore, it's a hierarchical tree map. And this hierarchical tree map can help us to see how big the influence of different categories of attributes is towards this AI decision of approval. So we can see that we have the financial category, the personal category, and the loan category. And here it is shown that the financial category had the biggest impact towards this approval decision, while on the other side, the loan category had the biggest impact that would have influenced the AI towards rejecting. But of course, it was a smaller impact, so it was an approval decision in the end. And after having gained a first overview, we can now enable the detailed view. And here we can see that the balance was a quite important attribute that was contributing towards this approval decision. And when we just remember the first dice counterfactual that we looked at, it also makes sense because there, for example, the balance had been changed. And if we go through this, then we can also see that, for example, savings, so the between 100 and 500 euros of savings also had a rather bigger impact towards this approval decision. And keeping this in mind, we would now like to further investigate what influences the model. And when we want to do this, and we can use our live computation of a changed AI recommendation. And so here we can modify the model. And now we just remember our counterfactual, for example, and we remember that there a change in balance was done, and also in our LIME graph, balance had quite a high impact. So now we want to know how big would an impact actually be if we just change to no account here. And we can instantly see that the new AI recommendation of this changed instance, where everything is the same and just the balance would be changed, already has substantially lower confidence. And now we just think, okay, what would happen if also the history would be different and the applicant had a delayed payment of previous loans? And we can see that there's a further drop in confidence. And now we also change savings so that the applicant has no savings. And we can see that now the AI would not recommend to approve anymore, it would recommend to reject. And when we want to just have some visual overview about these changes and how they actually change the AI recommendation, we can now press the Generate New Explanation. And we have some sort of a what-if analysis graph down here, where on the left we have the tree map for our original loan application, where we can see that balance was a very important factor that was contributing towards the approval. And now we have our changed instance and the changed application. And we can see that here the now account at balance was an important factor that was contributing towards rejecting the loan, for example. So here we can also just go back to the simple view again, just have this quite basic overview over the different categories. and we can also reset this, and then we're just back at our initial tree map. Then we also have a third explanation method down here, which is SHAP. And SHAP has a different way of being computed, which takes a little bit longer. Also the values have a slightly different interpretation, but we use the same visualization as for line, and we also have a detailed view here, which allows us to gain more insight into which attributes are important.